If you would, please go ahead and open up the mole-to-mole problems number 2. Like I went over previously, this entire equation right here is kind of like a recipe. The recipe here tells us that the coefficient in front of aluminum is 2. That means that this recipe requires 2 moles of aluminum to react with 6 moles of hydrochloric acid. If that amount reacts, then you will get a product of 2 moles of aluminum chloride and 3 moles of hydrogen. So it's a recipe that tells you how much has to go in order to get a certain amount out. So for example, if you have 2 moles of aluminum going in, then you know that according to this equation that the recipe says that 3 moles of hydrogen gas is going to come out. So we know that relationship by looking at this reaction. Take a second, pause this, discuss with your shoulder partner for a minute some other relationships that you can come up with based on looking at this relationship, at this equation here. If you look, there's actually a lot of different equations you can come up with. 2 moles of aluminum is going to need 6 moles of hydrochloric acid to react with, and 2 moles of aluminum is going to need 3 moles of aluminum chloride to react with. Or we can also look and see that 2 moles of aluminum is going to produce 3 moles of water. And we can also see that 6 moles of hydrochloric acid is going to produce 2 moles of aluminum chloride. And we can see that 6 moles of hydrochloric acid is going to produce 3 moles of hydrogen gas. And we can see that 2 moles of aluminum chloride is going to produce 3 moles of hydrogen gas. So there's a lot of different relationships that you can come up with, and we're going to use those relationships to figure out how much of a particular material we need if we're given a certain amount of the other piece of the recipe, and of another ingredient that we have. So let's take a look at the first one. How many moles of hydrochloric acid, that's what we want to know, are we going to need to react completely with 0.546 moles of aluminum? So we're looking at the relationship. We want to find out how much hydrochloric acid, and we already know that we're starting with 0.546 moles of aluminum. So we're always going to start with what we're given, 0.546 moles of aluminum, and we're going to set up our ratio. We're going to multiply that by the relationship we know. According to our recipe here, we know that 2 moles of aluminum have to go in to react with 6 moles of hydrochloric acid. And so the reason I put my coefficient of 2 on the bottom is because that's the one that goes with aluminum. So I can cancel out aluminum, and so now my answer will be in moles of hydrochloric acid. Pause the video here, calculate it, and then see if you got the same answer as me. You should have gotten 1.638. We do want 3 sig figs, so I'm going to go ahead and I'm going to round that to 1.64 moles of hydrochloric acid for my answer on that one. If you would, go ahead, pause the video, try to do number 2 with your shoulder partner, and then after a minute of you trying to do that, we'll hit play again and see how you did. So this is the answer that I got for that problem. You can see my setup. I put moles of aluminum on the bottom because that's what I start with, and I use the coefficient in front because that tells me that 2 moles of aluminum have to react to produce 2 moles of aluminum chloride. And since aluminum chloride is what I want to get to, that's what I'm putting on the top. Notice that this is basically a 1-to-1 ratio. If I reduce that ratio 2/2, so that means that if I've got 2.45 moles of aluminum, then I'm also going to have 2.45 moles of aluminum chloride coming out. We can also use the ratio method that we had before instead of the multiplying by a conversion factor that crosses out. So you can also set this up as 2.45 moles of aluminum, and we want to know how many moles of aluminum chloride we would get, and this we can set equal to the ratio we know of 2 moles of aluminum is equal to producing 2 moles of aluminum chloride, and we can still do our method of cross multiplying and then solving for x, and we would get the same answer here. So this is just another way to set it up where you're setting it equal to each other and cross multiplying for your algebra versus the method here where we are setting up our ratio and then we are multiplying it and crossing out and canceling our units, making sure the same units are on the bottom and the unit that we want to get to is on the top. So just remember your mathematical rules for whichever way you do it. Go ahead and pause this video, try 3 and 4 with your shoulder partner, and then we'll take a look at the answers. So here's my work for number 3 and number 4. So I'm starting with 1.88 moles of hydrochloric acid. So I have a 6 as a coefficient in front of hydrochloric acid. It goes on the bottom of my ratio. I want to know moles of hydrogen gas, and there's a 3 in my recipe as my coefficient in front, and so I get an answer of 0.9425. Now, if you did the ratio method, I can do the same thing. I'm starting with 1.885 moles of hydrochloric acid. On the equation, it says that 6 moles of hydrochloric acid are going to react with 3 moles of, this should be H2 here, of H2. And so I can cross multiply and I get this work. And then when I solve for my x, I get the same answer as I did using the conversion factor. So you can see how the two methods here relate to each other and how they're similar and how you get the same answer doing it with multiplying by the conversion factor or setting up the relationship and then cross multiplying to solve for x. I did the same thing on number 4 as well. I did it both ways, so you can see I start with my 14.2 moles of aluminum chloride. I don't want moles of aluminum chloride anymore, so it goes on the bottom, and according to my equation, I have 2 moles of aluminum chloride up here that are going to be reacting with 3 moles of hydrogen gas. So that's what this is asking me for. It's asking for the other product. So I started with the blue. I'm trying to find out the red up here. So it goes there, and I calculate it. And I have it set up so that my units cancel out with each other here. Again, I can do it the same problem right here using the cross multiply ratio method. I look at my equation and I see that I'm starting with 14.2 moles of aluminum chloride. So I'm going to set it equal to what I know about aluminum chloride. And on the bottom, I'm going to put what I know about my moles of my unknown, which is H2, and I'm going to put my X underneath. I cross multiply, here's my work, and I get the same answer there. Go ahead and pause the video. I want you to try and do 5, 6, and 7 on your own, and then we'll check in and see how you did on those. So I've completed 5, 6, and 7 in the traditional method in blue. So you can see that we start with moles of oxygen. My moles of oxygen goes on the bottom. I use the 11 coefficient from my equation up here, and then I use my 8 coefficient from my equation for moles in order to get to moles of water. So you can see my answer for number 5 and my answer for number 6. That's the traditional method in blue. Number 7 is the toughest. We're starting with grams of C7H16. But the thing we have to remember is that the equation that we have up here, that's our recipe, is telling us mole-to-mole ratios. It's telling us how many moles of each material we need and how many moles are going to be produced. So my first step, I actually have to take that 45 grams of C7H16 and I have to convert it to moles so that I'm able to actually use this equation up here. and use that mole to mole ratio. So once I calculate the molar mass of C7H16, I can use that and calculate my moles of C7H16. And then finally, I can use my typical mole to mole ratio using the coefficients on the chemical equation in order to get me to my moles of CO2. So that's the traditional method in blue. I have done the method in red as well. So you can see over here with the cross multiplying, you get the same answer for each of them. You can see my work of where I'm cross multiplying in order to get 29.6, and then I cross multiply 11 times x, and I solve for my x to get my answer right here. Same with the other problem. I've got what I start with and my unknown. I cross multiply and I get the same answer here. You're welcome to go back to this video. I have posted it on Schoology and you can look over all of my work and my problems. The last one, using the cross multiply method, you can still use the cross multiply method. You start with what you're given, and on the bottom you put what you don't want to know. Well, we have to look at the equation, and you can kind of see up on each of these problems, I put 1 mole of C7H16 is 100.237 grams. My reaction says that I'm going to just need 1 mole. If this problem was asking for maybe how much oxygen, I would actually need to calculate, because I've got 11 moles going in, I would have to calculate how much 11 moles of oxygen weighs. So I put that there. Or if this problem was actually asking for moles of carbon dioxide, or grams of carbon dioxide, I would have to calculate how many grams 7 moles of carbon dioxide is. But I can still use my ratio method. I simply start with my grams given and put my moles of what I want unknown on the bottom, and I just make sure that my units line up. So my grams of C7H16 that I would need according to my equation, well, 1 mole is what I need, and 1 mole of C7H16 is 100.237 grams. So that's why I put that up there, is because this equation says I need 1 mole of it, and 1 mole has that mass. And then I use my 7 moles of CO2, that's on the bottom, and I use my equation there, and then I still cross multiply.